So, without further ado, thank you very much for coming. We're super excited to see you all. There is a little bit of a not-so-secret surprise at the end, which may be one of the reasons we have a lot of attendees. But I'm sure you're here to hear about the amazing Dynamic Perspective API as well. So my name is Peter Heinrich. I'm an App Store developer evangelist, which means that I spend most of my time helping developers bring their apps to the Amazon Fire ecosystem, mostly games, but any app is fine with me. I enjoy working with developers. A little bit later, I'm going to be joined by my colleague, Bilgam Chucker, who is one of the senior software design engineers associated with the Fire phone. So he's going to give us a little bit of behind the scenes into the development of this API. So I thought what we could do today is start with a little bit of background and then discuss the origins of the opportunity as Amazon saw it. So Bilgam will pull back the curtain a little bit on the creation process as the Dynamic Perspective team brought the feature to life. And then finally, I'll show how easy it is to leverage all of their hard work when you want to bring this feature to your own apps and games. And then, of course, we'll wrap up with some links and some resources if you want to learn more. So mobile devices, and especially mobile phones, are everywhere, and they're everywhere redefining how people interact with mobile devices. So there's been an immense effort that's gone into innovating instant access to data of all kinds in brand new contexts, in brand new environments. And as a result, the infrastructure to deliver it has advanced light years, seemingly overnight. But the fundamentals of user interface, the display elements, they really haven't kept pace, with a few exceptions. So the basic 2D paradigm has pretty much remained the same. So I mentioned there were some exceptions. You might consider, for instance, gestural input or voice recognition of the Kinect, or the use of touch and accelerometers in mobile devices. There have been 3D treatments, like Flip 3D on Windows or the Compiz desktop cube on Linux. And they're trying to expand the flat presentation plane. And of course, the rise of Oculus Rift shows just how many people really believe that VR can become a compelling mode of interaction. So these efforts have had mixed success, unfortunately, primarily due to two primary factors. So fundamentally, UI must be lightweight. I mean, by definition, it's the window into and the control over the device's operation. So it has to be responsive, it has to be performant, but it has to yield enough processing power to the applications that it's executing in order to allow them to function. And so UI changes will never be adopted, no matter how innovative they are, if they don't improve the user experience. And second, there has to be a clear and easy way to adopt this new paradigm. Migrating shouldn't introduce new, non-trivial layout requirements, for example, or force developers to learn specialized skills just to implement them. So thinking about all these constraints and taking these advances into consideration, Amazon could see there was still some issues that needed to be addressed. Thumbs. We've all got them. They always obscure what we're trying to do. It's particularly problematic when you've got a very small screen and you've got lots of information that you're trying to convey in a very small amount of real estate. And then really, I mean, if you're working with a device every day, are you going to use some kind of strange personal appliance to interact with it? So of course, we saw this as a challenge, right? There's this implicit need for richer display and more expressive user input methods, especially since so much of the new device interaction happens up close. It's really literally in your face. So we actually dedicated a team to exploring how we could increase data flow between the user and the device using alternatives to the traditional flat UI. We were particularly excited by the whole idea of the device in relation to you as opposed to the device in relation to the world. So we're here today to talk about the results of those efforts. Dynamic Perspective allows your app to respond to how the user holds, views, moves the device, and it leads to new kinds of interactions. It's built into the Fire Phone, obviously, which although it's only been available for a few months, kind of gives us a glimpse into what the future may hold. So let's just, as an example, I've got a Fire Phone here, amazingly enough. And I think you can see this. This is our mapping application, and you can see, it gives you a kind of a cool view. This is where we are right now. This is real time. Anybody staying at Treasure Island? So you can see people walking around. This is amazing. No, I'm just kidding. Okay.
Find my wife.
She's at Barney's right now. And I also wanted to give a demonstration of this in actual use, so I'm just going to pick one of these games. This is actually an Amazon Game Studio game. That doesn't influence my choice, but I just wanted to demonstrate how you could actually use this feature in a way that's constructive, in kind of a cool and innovative way. Bear with me. This was supposed to be on a separate device. Sorry. Okay. So we'll play this. Boom. And I think you'll be able to see this. But basically, it gives me an overview of the level, and then I can actually use Dynamic Perspective to get a better view of what I'm interacting with. I can move around, and so it's using a combination of these sensors in the corner and the motion, basically the MEM sensors, the motion sensors in the device, to create this kind of hybrid experience where I can look around the corner and see that I need to go down here and pull this guy down. Oops, grab him. I go this way, that's why. Boink. Boink. Oh. So this is using Dynamic Perspective live in an actual game. And a lot of the gameplay revolves around being able to look around the corner and see the play field from a different perspective. No pun intended. So based on those constraints that I mentioned earlier, we constrained our research accordingly. So we wanted to make sure that our results, the results that we generated, were actually performant, and that they also have a reasonable power usage profile. We didn't want to be profligate with the battery. And of course, we also wanted to make sure that they were easy to adopt by the typical Android developer. This shouldn't be rocket science to add these new features to your applications. So with these basic guiding principles in place, we placed these two big bets on our exploratory research. The richer input functionalities, such as head tracking and motion gestures, and then also 3D controls, more richer output functionality like 3D controls and Parallax. So of course, we're customer obsessed, and we very much saw these first efforts as basically the beginning steps towards a long-term vision for an improved customer user interface across many device types. So with that, I'd like to introduce Bilgam Chucker, who's going to give us a little bit of a behind-the-scenes look into the making of this feature set. Thanks.
Hello, hello, hello. Okay, there we go. Thank you, Peter. Hello, everyone. Let's first see if this runs. Yes, good. My name is Bilgam. I've been part of the Dynamic Perspective UI rendering team for the last 2.5 years. And throughout this time, we've been exploring a new dimension in UI, quite literally. And today I'm going to talk about some of the highlights from that journey. So when we started this journey, one of the first things we realized was that this exploration was going to be bigger than us. If you think about it, the notion of 3D enables so many different possibilities in the field of human-computer interaction. It's exciting stuff, but there's so much to explore. Because of that, one fundamental tenet became very clear very early. Our technology had to be easy to use so that others could join us in this exploration. Now, 3D can be inherently more complicated than 2D. We realized that there was a risk of making it more difficult for the app developer to create a 3D object and place it in a 3D world versus a 2D object in a 2D world. It could also get more complicated for the end user of the app. They could struggle with seeing things because in an arbitrary 3D space, things could obscure each other, and it could be harder for the user to interact with them through touch. Because remember, touch is still a 2D problem. You're touching a 2D screen. So in order to avoid some of these risks for both parties, for both devs and the end users, we decided to stay familiar, to stay coherent with well-known Android paradigms, to start from there. After all, many of the developers and many end users are already familiar with Android. We took those Android paradigms, and then we enhanced them with some 3D notions, namely the ability to place 3D objects and the ability to play with depth of objects. Of course, mere 3D would not be enough. We wanted more sizzle, more zest, and more special effects, so we added those. And finally, all of that sizzle would be immediately lost if we didn't make this thing fluid and power efficient. So let's talk about how we try to stay familiar to Android developers. Now, as an Android app developer, you can continue to use your 2D layouts. That is still the basis of your app development. But now, you can place 3D objects into various places. We provide a lot of drop-in replacements for many of the common Android views. So an app developer who is interested in experimenting with this stuff can just go ahead and go to their layout file and find something that they want to change, like the button, and turn it into a Z button. And they can get a 3D button into their app without touching a single line of Java code. This is strictly a change in the layout file. I'll talk about the Z container bit there a little bit further. Now, this kind of compatibility is achieved through a series of very careful architectural decisions. All of the views we provide inherit from their Android counterparts and support the same interface. So when you replace a view in your app with one of ours, it continues to respond to the same set of calls that the rest of your app makes to talk to it. Through this kind of a system, it's easy for you to adjust and adapt different parts of your app to this new technology. Of course, if you're willing to change your Java code, you can do even more with these because they have an additional 3D interface. And also, we support more advanced custom view scenarios, various customizations. You can, for example, take one of our views, inherit from it, override behavior. You can also use our toolchain asset creation tools to change visual behavior, in which case, again, you don't have to change any Java code. But how do we do this behind the scenes, technically? We have two main technologies to achieve this. First, we have a 3D engine, much like the ones you see in games, only heavily optimized for our purposes. Using this engine, we can render your 3D content and place them in what we call Z-view hosts. Z-view hosts are regular Android views, 2D Android views that can participate in a 2D Android layout. And through their rectangle on the screen, we can render 3D content. You can think of them like 2D LCD screens hanging on a 2D wall, through which we are showing you 3D content. They provide the integration boundary between 2D and 3D in your app. Secondly, we give you the ability to play with depth. The backing technology for this is what we call depth planes. They're an efficient way that enables you to play with the depth of objects on the z-axis, back and forth, in an efficient way. Ultimately, the key point here is we want the end user to have a rich visual experience while maintaining an easy-to-use through a 2D touch interface type of experience. And we want to make this easy to achieve for the app developers. Now, we believe this particular combination of 2D Android layouts, Z-view hosts, and depth planes provides an elegant solution to this problem. Using this combination, an app developer can easily create a 3D app that is easy to use and delightful for the end user without having to learn more advanced 3D concepts necessarily. Because you can go full out 3D with our technology too. We don't disallow that. But to be able to do that efficiently, you would have to learn some new skills. And if you have them already, you're fine. But you would have to know things about linear algebra and 3D homogeneous transforms in 3D space, etc. If you don't want to invest in learning them, you can stick to this paradigm and you'll get 3D in your app. Of course, here's the fun part. When you bring a proper 3D engine into your app, now you can achieve much more visual richness. We are no longer looking at gradient-filled rounded rectangles. We are talking about complex materials with interesting surface properties like textures, shininess, bump mapping, reflections. We can make objects out of these materials, put them in scenes, and then light them with complicated lighting that, like photographers use in their studios to light their scenes, with multiple lights from different angles with different colors. Some of those lights can cast rich shadows, further enhancing the aesthetic as well as the 3D perception. And finally, everything on the screen, every object, every material property, every light property can be animated in infinite combinations. We even support more advanced animation systems like skeletal animations that you would find in games, like the example you see here in this lock screen with the tentacles and the astronaut running. So anybody who ever played a 3D game on their phone knows how fast those things can drain your battery. I've seen games that can do this in half an hour. So all of the benefits and all the sizzle and special effects we add does not matter at all if your battery runs out in half an hour. Nor will this delight anyone if this is running in 5 frames per second. So performance and power efficiency had to be there. And in mobile GPUs, power use and performance are interrelated in various interesting ways. In the interest of time, without going into too much detail, I'm going to talk about one guiding concept that we thought about a lot, which is your GPU duty cycle, for lack of a better term. Now, let's say you're rendering in 60 frames per second. That means you have about 16 milliseconds for each frame. So imagine those green dotted lines, vertical lines are 16 milliseconds apart. If you take 10 milliseconds to render your frame, the mobile GPUs are really great at quickly going to sleep for the rest of the frame time, which is the 6 milliseconds, and save power. So if you can optimize yourself to render that same frame in 5 milliseconds instead, you can almost double your battery life. Now, the interesting thing here is that means the FPS alone is not necessarily the indicator of battery usage. So you can have a 30 FPS game that is using almost all of its frame time, spend more battery than a 60 FPS app that is using much less of its frame time. That is the key bit too. Of course, I'm a little simplifying because GPUs can actually go into lower power states if this happens, which ends up with the same result for our purposes. So the key thing here is the perf optimizations you make to improve your frame time also improves your power usage. So with those fluidity and power use goals in mind, we first focused on getting at 60 FPS. And we didn't stop there. We kept reducing our frame time to save more power. Countless teams did so many different optimizations to so many different components throughout the entire project lifecycle. The 3D engine was optimized again and again through some common 3D optimization techniques like minimizing the number of state changes, minimizing the number of draw calls, atlasing textures, optimizing shader ops. One level above that, the ZView hosts were optimized again and again to ensure that they only updated or rendered at the minimum amount of time. And the depth planes were deeply integrated into the way Android runs its render traversal to avoid additional blitz. And the head tracking was fine-tuned to make sure we didn't redraw because of minute head movements. Many people from many disciplines and many teams came together to make sure that this experience was fluid and power efficient. Now, this all makes one thing clear going forward. Bringing 3D to consumer devices as part of their everyday interaction is now easier than ever, and it enables a lot of possibilities for different people from different backgrounds. Developers, designers, artists can now create 3D use cases that we potentially don't know that we need. Or they can find a lot of interesting new use cases that enable end users to become more productive, to enjoy their devices, their work, their content more. So to unlock all these possibilities, we worked really, really, really hard to solve some of the deep technical problems and hide away the complexity in the hopes that it becomes a much easier thing to adopt. We feel like all we really need now is more explorers. So with that, I'll give it back to Peter, and he'll show you how easy it is to experiment and play with some of these concepts. So enjoy.
Thanks, Golan. So who's comfortable with Hermite transformations and systems of linear homogeneous equations? 4 people, okay. There's not gonna be, that's not on the test, don't worry. Okay. So thanks, Bilgam. Really interesting. I'm gonna talk a little bit about each of, a couple different components of the API. I'm gonna start with just how do you migrate? So you've got a 2D application now, you wanna incorporate some of these cool features. What's involved there? So we actually have a 3D UI component library that's provided by the Dynamic Perspective API, and it's called collectively Euclid, or the Euclid UI. And it includes several different kinds of objects, including controls, such as buttons and lists, checkboxes, that kind of thing. Containers to simplify the positioning of UI components in 3D as well as 2D, so along that z-axis. And also convenience classes to provide some easy-to-use patterns like shadows and parallax, like Bilgam mentioned. So it also provides some specialized themes for use with 2D and 3D controls. You can actually mix and match 2D and 3D controls in your apps. If you're going to use any 3D controls, though, you need to use these specialized Euclid themes. So in order to use Euclid, just from a high level, the first step is simply to use the theme. You're going to want to substitute the Euclid equivalents for the standard Android controls. So for instance, a Z button for a button, just as an example. You're going to want to wrap all of your controls in one of those Z containers, which is the thing that actually adds depth and allows you to place those controls on the Z axis. And optionally, you can also provide a Z shadow receiver object at the root of your layout. So all of those 3D controls can actually cast a shadow onto this receiver to be displayed. And there's some real benefits to this approach, as Bilge mentioned. First of all, you can reuse most of your existing code. So when you migrate your app, you just make minor modifications to your layout, and you've got your controls at your fingertips. You can also use a standard Android activity, so you can just embed the controls in the view hierarchy, either singly as 2D, 3D, or a mix, as I mentioned. And if there's a caveat at all, it's simply that we don't have Euclid equivalents for every Android control, so some of those classes will not change. For instance, the list, or the grid, a scroll view, picker classes, that kind of thing. So the first step is simply to choose one of those Euclid themes, depending on your application. And it's simply it's a simple change to your manifest file. We're just going to choose whether we're going to use a light or a dark. And then it's just a question of actually using, for instance, a Z button instead of a regular button, wrapping it in the Z container so you can add depth to it and place it on the Z axis. And then, as I mentioned, optionally adding that Z shadow receiver at the root so that you can display the shadow that it's going to cast. And let's see. What's that? Oh, okay. Oh, thanks. Okay, thanks. Does that help? I guess we'll see. So here's an example of a 3D control. So this button, I don't know if it's going to be visible or not. Maybe if I move it closer, try to do autofocus. You can see there's a little bit of parallax in the motion of the button because the button is actually up off of the back plane. You can see there's parallax in the background as the button, as the phone changes position with respect to my face. So the Fire Phone also features dynamic perspective sensors, which are just cameras and motion sensors to allow for head tracking. And they work with the software to recognize and track the user's head with respect to the front of the camera. And then, of course, this gives head tracking information, makes it available to all sorts of different usages in games and other apps. And it returns all the data as an event, which contains information like true or false for face detection, the position and angle of the head with respect to the cameras, and a timestamp associated with when that event happened. And it also supports some power-saving options like pause. You can also use lower fidelity capture, and you can use just camera-only capture, so there's no motion sensor involved as well to save power. And you can collect this data in one of two different ways, either as a listener, where you just receive updates when the face changes, or the face doesn't change, the face position changes, or polling. So in that case, you're actually making a call for an instantaneous return of the data as it is currently. So if we wanted to listen for head tracking data, for instance, we just need to get an instance of the head tracking manager. We're going to register as a listener, and then we're going to override the on head tracking event. So that'll give us the notification of any changes to the position or orientation of the user's head. And then it's just up to you in that method to extract the coordinates and the detection results and use them however you want. And similarly, if we wanted to poll instead, it's a slightly different process, but essentially the same. We're going to start by getting the head tracking manager and then register a head tracking polar object. We're going to get a head tracking event from the event pool, and this is going to hold the data that we retrieve whenever we actually request the current head tracking state. We'll call sample to fill in the event with the valid data. And this is, again, this is a polling situation, so we're going to be reading directly from the latest head tracking data that's available to the system in real time. And then again, you can just do what you want with the data that you retrieve. So let's see, I've got another one here. So here's I'll try to get it closer to the camera. So this guy is a little blue ball, and you can see as I move my head, the blue ball moves around. And what's also kind of cool is it can actually tell the, let's see if I can do this with the camera now. If I get closer, it can actually detect the distance of my face from the device as well, which is kind of cool. If you want to zoom in, you're like, I can't quite see my wife at Barney's. Oh, there she is. Okay, then we also have the MotionGesture API. This is the other one I wanted to talk about. And it actually supports 3 different kinds of gestures. It has peak, which is essentially just a detection of when the face or the head is moving side to side, or the device, actually. It could be either one, because it's relative. We've also got continuous peak, which is measured as a percentage of how off-center you are. And then we've got tilt, which is a measurement of the device actually executing 2 different motions, which is tilt away and tilt back. Both of those have to be present in order for a tilt event to be registered. So again, very straightforward to implement these features. You just need to create, in this case, an instance of a gesture manager. You're going to register to receive the notification of any kind of gestures. And you do this by obtaining a gesture object of the type you intend to listen for, and then override the onGesture event to handle the gestures. So I've got an example here of, oops, I guess I'm not ready for my example actually. I want to talk a little bit about the tilt scrolling, which is going to implement one of these gestures. So in this case, you would use a tilt scroll controller, and we can use it to easily control the scrolling associated with any scrollable view by just layering it on top. And it actually supports scroll views, list views, grid views automatically. And the only issue is that it's kind of up to us to disable the scrolling when it wouldn't be appropriate. So for instance, if someone's actually touching your list, you don't want scrolling to happen. And we can do this by setting up some triggers on those events and then disabling the scrolling at that time. So as an example, let's just add tilt scrolling to a standard list view. First, we'll set up a tilt scroll controller when our activity is created, and then just set up our list view and list adapter as we normally would. Then we're going to bind our tilt scroll controller to the view we just created and the view group containing it, and create a trigger to fire when it's touched, and also when to fire when the center panel isn't currently the top most visible panel. So we don't want scrolling to happen in those 2 circumstances. And now I will show you, as an example, some scrolling. So here's just a regular, is it in focus? Focus. This is just a regular scroll view of some important cities in our country. And simply by moving my head, maybe, it needs to see me, that's why, okay. So now, if I move my head, it'll scroll, or go this way. So this is nice because, if I'm standing in the bus, for instance, and I'm holding on to the thing up here and my thumb doesn't quite reach to the scroll bar, I can just tilt the thing and tilt back, and it's kind of convenient. So we're super excited by this whole potential of this new user interaction, new modes of interaction, and in fact, we're so excited by it that we actually spent a lot of time and resources to advance the state of the art here and provide the technology to support it. So in the end, our goal was really just to create something that addressed an actual interaction issue faced by real customers, which I think we did. We wanted to make sure that it performed well. We wanted to improve the customer experience above all, and we wanted to make something that was easy to incorporate into new and existing Android apps. So Dynamic Perspective really is the first result of these efforts. And the next steps for you, please just, first of all, visit our developer portal, You can get more information about the SDK, more information about samples, and the SDK is basically a mouse click away. And this will let you start developing your own apps using Dynamic Perspective. Of course, we're here to help. There's tons of resources on the web, not least of which is our developer portal. You can also connect to us on social media. You can connect to me on Twitter. I'm happy to respond to any issues or problems that you encounter. I'm happy to answer questions. And of course, we have a very active community online as well. You can go for help. And then, just last but not least, there's this thing. We thought it would make it really easy for you to actually get going. We wanted to jumpstart this development process. So everybody who gets a card on the way out is going to get a free, unlocked, brand new Fire Phone inbox as you exit. So before you get up and dash for the door, I just have a couple notes about the process. First of all, everybody's going to exit through this door, the left door over there where Paul's waving his hands. You're going to get a card, a little card at the door. If you're not a U.S. citizen or a U.S. resident, you need to fill out a tax form, unfortunately. So they're going to be handing those out as well. And then just line up and get your card stamped and get your device. Thanks.
Thank you.